Until recently, all spectroscopic studies of 3I Atlas indicated a reddish color. The latest image of 3I Atlas from September 7, 2025, suggests that the glow around it turned green. The transition from red to green-blue colors might be associated with the steep rise in the production of cyanide, CN, as reported by the Very Large Telescope on August 25, 2025. The production of both cyanide and nickel without iron was found to increase dramatically, with decreasing heliocentric distance to the power of about 9. Pause for a few seconds and support me with a subscribe. This morning, the Atlas Telescope team released data dating back to March 28, 2025, showing that the cross-section of scattered light around 3I Atlas grew inversely with heliocentric distance to the power of 3.9 when the object was farther than 3.3 times the Earth-Sun separation, AU. Once 3I Atlas got closer, the growth was moderated to a power law index of 1.2. The Atlas team interprets this anomalous evolution as a shift from scattering of sunlight by dust, lifted from a reddened surface, to the production of small, optically bright icy grains, which change the opacity of the plume of materials shed off by 3I Atlas. The Hubble Space Telescope image of 3I Atlas from July 21, 2025, when 3I Atlas was at a heliocentric distance of 3.8 AU, shows an extension of scattered light towards the Sun and not away from it, as typically for comets. The Webb Space Telescope data from August 6, 2025, and the SPHEREx Space Observatory from August 8 and 12, 2025, showed that the plume of gas around 3I Atlas is dominated by carbon dioxide, CO2, 87% by mass, with traces of carbon monoxide, CO, 9%, and water, H2O, most of the remaining 4%. Combined with the path of 3I Atlas being aligned with the ecliptic plane of the planets around the Sun, having a chance probability of 0.1%, these facts make 3I Atlas interestingly anomalous relative to familiar icy rocks. 3I Atlas is different from the first interstellar object 1I Oumuamua, which displayed no signs of evaporation, but exhibited non-gravitational acceleration, and also from the second interstellar object 2I Borisov, which behaved like a familiar comet. Regarding unidentified anomalous phenomena, UAP, closer to Earth, Congresswoman Anna Paulina Luna will chair today at 10 a.m. EST a hearing of the Task Force on the Declassification of Federal Secrets in the U.S. Congress, titled Restoring Public Trust Through UAP Transparency and Whistleblower Protection. The first recommendation to Congress in the testimony of the U.S. Air Force veteran Jeffrey Nucatelli is, fund independent research and treat UAP study with the same seriousness as any other scientific field. This is exactly the narrative of the Galileo Project under my leadership. In an interview today on the program Morning in America of News Nation, I was asked whether the release of new videos or eyewitness details in today's congressional hearing is likely to restore public interest in UAP. I explained that this discussion is not a matter of public relations in a popularity contest, but instead a topic of great relevance for national security and science. Human history is full of misconceived notions. For example, the belief that the Sun revolves around the Earth was popular among humans even after the Earth revolved around the Sun 4.54 billion times. Once we all see credible evidence about the nature of UAP, we will be able to get to the bottom of it, and everyone would agree on what it means. When asked whether I believe that the U.S. government is hiding information, I replied that as a scientist, I respond to evidence and not to what people tell me. Scientific evidence is our best path to new knowledge, whether in the realm of UAP or 3I Atlas. The simplest way to tell the difference between a dogmatist and a genuine scientist is to flood both of them with scientific quality data. Whereas the dogmatist will shove anomalous data under the carpet of traditional thinking, an open-minded scientist will be thrilled to learn something new with an underlying sense of humility. Not only is nature more imaginative than we are, but it also does not care whether we figure it out. The insistence that everything in the sky is either icy rocks or human-made technologies will not rid us of cosmic neighbors if they exist out there. Take a moment and give us a like for this video. Thank you so much. How can we distinguish between the population statistics of interstellar rocks and a fleet of spacecraft that target that inner solar system? The answer is obvious. By the spatial distribution of their trajectories relative to the Sun. Whereas rocks arrive on random trajectories initiated near their parent stars, spacecraft aiming to probe the habitable zone around the Sun would favor paths directed towards the Sun. A few days after the discovery of the interstellar object 3I Atlas, I wrote a paper in which I argued that over the Atlas survey timescale of a decade, the reservoir of rocky material in interstellar space can only supply rocks smaller than a kilometer to the inner solar system. If 3I Atlas is much bigger than a kilometer, then it must belong to a population of large objects on plunging trajectories towards the Sun, possibly by technological design. As it turns out, the trajectory of 3I Atlas is also fine-tuned to align with the orbital plane of the planets around the Sun, having a chance probability of 0.1%. The brightness of 3I Atlas at a wavelength of 1 micrometer implies a nucleus diameter of 46 kilometers for a typical albedo of 4%. However, if 99% of the brightness stems from icy fragments around 3I Atlas, then the nucleus diameter is 10 times smaller, of order 5 kilometers. Given the unknown size of 3I Atlas and its unusually high speed of 60 kilometers per second, it is appropriate to consider how directional the trajectories of its parent population are as a function of its size above a kilometer. This calculation is addressed in a new paper that I co-authored with the exceptional graduate student at Vanderbilt University, O.M. Trivedi. The derived formalism is particularly timely in anticipation of the harvest of dozens of interstellar objects over the next decade by the NSF-DOE Rubin Observatory in Chile. The new paper builds upon the population-level consideration regarding the rarity of 3I Atlas and quantifies the resulting dynamical constraints. It follows velocity distributions that would allow an object of a given large size to be delivered through the observed trajectory of 3I Atlas for both natural and artificial populations. By considering both the small radius and large radius interpretations of 3I Atlas, the paper demonstrates how the rarity of the trajectory of 3I Atlas places stringent constraints on the abundance of massive interstellar objects. This analysis provides a new perspective on the emerging census of interstellar objects and directly addresses the question of whether the detection of 3I Atlas is dynamically compatible with a natural origin, or whether alternative explanations of a technological origin must be considered. The paper develops a dynamical framework to constrain the population of massive interstellar objects, like 3I Atlas, using 3 complementary approaches. First, it uses encounter rate analysis to demonstrate that the detection of interstellar objects with radii of tens of kilometers cannot be reconciled with a purely random background of large rocks, implying the need for significant flux enhancements. By applying the so-called Eddington inversion method, the paper establishes how steep the density profile of the parent population of 3I Atlas must be towards the Sun. The discussion is then extended to the so-called Liouville mapping in energy-angular momentum space, which propagates the interstellar velocity distribution inward under explicit conservation laws, showing that the required size-dependent enhancement of encounter rates can arise from anisotropies that favor low angular momentum trajectories directed towards the Sun. These results suggest that the detection of interstellar objects with a size above 10 kilometers is dynamically consistent with strong gravitational directionality towards the Sun. This directionality suggests new physical mechanisms like gravitational kicks from a nearby star system or a local structure in the galactic environment to produce the required velocity anisotropies. The other possibility is an orbit design of interstellar objects of technological origin. Future discoveries by the Rubin Observatory will provide the crucial statistics needed to test these different possible origins. This morning, I received a note about commercially available T-shirts inspired by my recent scientific research on 3I Atlas, as well as the following email on the same theme of financial benefits. Hope you're doing well. I wanted to let you know about an interesting market on Polymarket right now, regarding whether the U.S. government will officially confirm the existence of extraterrestrial life by the end of 2025. The way the market works is simple. It resolves to yes if the president, a cabinet member, a member of the Joint Chiefs of Staff, or any U.S. federal agency makes a clear statement that extraterrestrial life or technology exists by December 31, 2025. If not, it's a no. It's all about timing, and the rules are pretty flexible. Even just a tweet would work. Let me know what you think. Appreciate any help. Your fellow American. My reply was short and simple. Frankly, my main interest is not in making money, but in the question of whether we have a cosmic neighbor and what its impact might be on the future of humanity. This is a much bigger context, within which money would not maintain the same meaning or be used for the same purposes by future generations.